All right, so we're looking today at Calculus 30, Section 1.4 in Red Stewart Calculus text. And we're talking about using limits to find the slopes of tangents. Okay, very, very important lesson here. We're going to learn about the first formula that we're going to use limits now to calculate the slope of the tangent. We have talked about secant lines, and in this diagram that I have here, you can write this, you can sketch this out if you want for your notes. It is in your textbook there on page 30. But we've used secant lines to approximate, to guess what the slope of the tangent line would be, right? Do you remember that? So from 1.1, and I'm going to mess this diagram up just a bit. Let's say that, let's see, this is a secant line, isn't it? So if we took the slope of this secant line, it would be not the same, but it would be kind of close to the slope of this tangent line right here at x equals a. But it would be better if we could find the slope of 2 points that are closer together. And we went through all this, right? So as these points come closer and closer together, we get closer and closer to what the slope of the tangent line would be. So we've been through all that. And we've also learned how to calculate limits of a function. We've learned that we can have some skills that we can manipulate equations, change them a little bit so that, I'm going to go back here, we can rearrange equations around so that we can cancel out some factors. These were some more difficult ones here. Certainly, factor and divide out common factors. So we've learned how to take limits of functions. So what I want to do here is I want to just take a moment to explain something. So we know how to take the slope of a secant line. And here I have the definition of what a slope is. The slope of line PQ is given by the rise or the change in y divided by the run or the change in x. What's another way to write that? Well, another way to write that is, and you know this, y2 minus y1 over x2 minus x1. If I don't know exactly what x1, y1 point is, or exactly what x2, y2 point is, I can substitute this for the above. Now watch this. Y2, this one right here, can be represented as just f of x, if this is the x value here, okay? And x2 is x. So there's the point x, f of x. All right. Now this point, I'm giving this a different x value. I'm giving it the value of a. Now a is going to be the point that we're really focused on. That's where we're going to want to find the slope of the tangent line too. So a is the point of tangency. So if we had x equals a here, then this point could be stated as a comma f of a. So a and f of a would go in for x and y1. All right, let's erase this here and erase that too. So this is very important. I hope that you see, and if you look at the graph, y2 minus y1 is what I see up top there. That calculates the difference in the y values. X2 minus x1 looks like x minus a. See, x2 minus x1. So this is another way to show the slope given this notation. Okay. Now, in the past, like I said, we have taken the slopes of a number of secant lines as these points come closer together. But what if we took a look at this? What if we said, here's the rational expression for the slope of a secant line, where x and a are two different values, and f of x and f of a are two different y values. So what happens if x approaches a? Ooh, that sounds like a limit. And that's what we're going to do. We are now going to look at this slope formula, and I am going to ask myself, what would this slope value become if x, this x right here, were to approach a? Ooh, that's a limit. So guess what? Limit of this function, that's f of x minus f of a over the difference in the x values. If I let x approach a, the limit of this slope between the 2 points that are getting closer and closer together, that limit is going to be equal to the slope of the tangent line. So that's the basis of this whole lesson. We are going to combine the slope of a secant line, which we've calculated before, and the skills that we've learned by finding limits of functions, rational functions. We're going to put them together. So, you know, I've thought for years and years, like how this is, to me, this is, I remember learning this for the first time. It was kind of like, whoa, wait a minute. How can you just let those points come together? How do you just smash them together and then you end up with a number? Well, hopefully you see that finding the limit of a rational function, right, is basically allowing us to say, okay, I know that there's a point that's going to be undefined here, but how can I rearrange this function to make it mimic another function, another looking function, and then I can use my substitution to see what that value would be. And those two concepts we're going to put together here now. So notice, and let me just scroll down here. I've highlighted this, okay, this right here. You've just written this down. This is called Formula 1, all right? There's going to be two formulas. We'll learn the second one in the second video today, second part of the lesson. But this is how we can find the slope of a tangent using limits. And of course, we're going to do lots of examples here to show this, okay? So this is your Formula 1, and we're going to take a look at a real-life example here. Okay. Now, this is not the easiest real-life example, but I have faith in you guys. You guys will be able to understand this. So let's say we have a parabola. Okay, and the parabola is defined by, you can see the graph over here on the right. I just did this on Desmos. I also drew a sort of a mock tangent line here, so we have some kind of visual of what we're dealing with in this question. So the function is 2x squared plus 4x minus 1. That's this parabola right here, the red. My question is, what is the slope of the tangent line at x equals 2? At x equals 2. Okay. Well, let's just go over here and look at this graph a little bit. Here's x equals 2 right here. Here is f of 2, that point. It's on the red line. It's f of 2. And what is f of 2? Well, we can find out what f of 2 is really quickly by just putting 2 into the function, right? And so what is this? 2 times 4 is 8, plus 8 minus 1 is 15, okay? Now, we're going to need to know what that is. We're going to need to know what this value is. F of 2 equals 15. Because we're going to need this for our formula that we just learned. So this is like, that 2 there is going to be the point of tangency, okay? So this a, x is 2, which really in our formula now, that means that a is 2, okay? So that's x equals a. A is 2. The x values, well, there's just going to be other x values over here, okay? And we are going to let those values of x and of their corresponding y values get closer and closer to 2. And we're going to do that by using our new formula, okay? So remember, we're going to use a limit as x approaches, now what's a here? 2. As x approaches 2, of f of, what was that, f of x or f of a? Well, it's f of x first, okay? Now, what is f of x? Well, f of x is actually this right here, right? So I'm going to actually just skip ahead here, and instead of writing f of x, I'm going to actually write the value of f of x because I've already kind of put these values in. So let's do that. F of x is actually 2x squared plus 4x minus 1. You see that? That's your f of x. And maybe I'll just bring this down so we can see both of them on the same screen. Okay, I'll just put that up here. So the f of x is always written first, isn't it? So the f of x is written first, and yes, f of x is right here. It's defined as this right here. Now, minus f of a. So I've already done this work, but I'm going to rewrite it like this anyway. So if you hadn't done this already, this is what you would do. Because this is f of a, okay? So f of x is just the formula for the quadratic or whatever this graph is, okay? It's just the equation of the graph. And f of a would be our target number, which is a is 2, inputted into the equation, okay? F of x, right here, f of x, that's f of x, minus f of a, See that? All right, now divided by, what is it? X minus a. So that's x minus 2. So this is how you go about setting up your limit. So again, this is the definition for the slope of the secant line connecting x and a and f of x and f of a. And we are going to take the limit as x gets closer and closer and closer to our a value. Okay? So again, I'm going to copy out this limit notation. X approaches 2. And I'm going to try to simplify things a bit here. Well, I'm going to leave this alone for now. And we've simplified this already to be 15. So that's going to look like that. We're going to gather like terms next. Okay, so remember, right now we can't just plug x equals 2 into this because we have a 0 on the bottom. So you're going to try to simplify the top, factor it, and see if you can factor out an x minus 2 from top and bottom to get rid of it. And spoiler alert, because this is a continuous function, and because we're setting it up like a slope between 2 points, there's always going to be 2 points there, so we're always going to be able to simplify this. We're always going to be able to rearrange this so that this will work, okay? Watch what I mean here. So the limit as x approaches 2, and this is actually 2x squared plus 4x. What's minus 1 minus 15? That's negative 16, right? Or minus 16, okay? Now I see that I have a greatest common factor up top there, so to begin my factoring, which is what you want to do now to try and manipulate this rational, I'm going to take out a 2 first. So again, this is every step. You should be showing every step like this. It's not going to take you forever because you're going to get quick at it. And if you show every step, you're not going to make any mistakes. Well, very few anyways. Okay, so do exactly like I'm doing as you learn this. So that 2 can't be divided out. We don't have a 2 on the bottom as a factor, so just leave it there. Okay, I'm going to switch up over here. And now you're basically just trying to factor and simplify. So I've got 2. I'm going to write this trinomial here as a product of 2 binomials. Can I do that? Well, I need 2 numbers that multiply to negative 8 and add to positive 2. It looks to me like 4 times negative 2 would give me negative 8, and 4 plus negative 2 would give me positive 2. So what is that? X plus 4 and x minus 2. Oh, this is looking great. Again, you should run into this where you'll have a factor that is the same on the top and bottom, and you're going to be able to factor those out. So as I continue, one final step here to show this, 2x plus 4. And you can rewrite that, whoops, of course, as 2x plus 8. Go ahead. But now you can substitute. You see, now this is all boiled down to just a linear function that this big slope function kind of resembles. All right? And now I can just substitute x equals 2. So now I go 2 times 2 plus 8. And that's going to be 4 plus 8 is 12. So this is the slope of the tangent line is 12. And if you look at the graph that I made here, and we want to just check to see if our answer is reasonable, then what you would do is you would kind of take a look, a little bit tough to see here. But the rise over the run, so let's say we've got about, a 15 here, and we've got about, 1.3, so 15 divided by about 1.3 1.26 or so. 15 divided by 1.26, that's a rise over run here on this scale. Gives us about 12, so it's perfect actually. All right. So that's your first question. That's a bit of a long, you can do it. But that is how we use limits to find the slope of a tangent. Now, I am going to get you to do this one on your own, okay? And arguably, this is a little bit of an easier function to work with. So go ahead and do this one on your own, and I will show you my solution in a few moments. So give that one a try. Okay, so this question here, what we're going to do is we're going to find the limit as x approaches a of f of x minus f of a all over x minus a. And the point is the x value is 2 and the y value is 0. So it's kind of nice we get the full point here. We know what f of a is. It's 0. So notice this is a and this is f of a. So when you're given a full point like this, it's awesome. A little less work for you. So the limit as x approaches 2, right, that's our a value, becomes f of x is 2x minus x squared, minus f of a, if you put in 2 in here, you get 0. Divided by x minus, what's a? 2. Okay, so I'm going to gather some like terms. I'm going to try and factor the top to see if I can get x minus 2 as a factor on the top. Because I can't plug in 2 into the function right now. So what does this equal? Well, I'm going to rearrange this a little bit. Negative x squared plus 2x. That 0 is just nothing there, right? Okay. So I haven't factored anything yet, but it looks like I can pull out, what, a negative x? Okay. If you pull out a positive x, you're going to see that the top and bottom aren't going to match up real well. So I'm going to take out a negative x, and that's going to be x minus 2. Okay, so again, negative x squared. If I take out a negative x, I get negative x times x. If I take out a negative x here, I get negative 2. So that's where the common factor is going to come from there. Okay. Those two factors can divide out, and I'll just transfer this up over here. I've got the limit of x approaches 2 of negative x, and so I've got negative x approaching 2, so I've got negative 2, okay, for the slope of the tangent. So negative 2 is your answer. Do you guys get that for an answer as well? Okay. All right. Why don't you try one more here? Let's try another one here. Let's do this one. So y equals. Let's see if I can pick a good one here for you here. Let's do y equals x. Whoops. Why did I shoot that twice? Y equals x squared. X squared minus 6x plus 5. And let's find the slope of the tangent line at x equals 2. Okay? So find slope of the tangent line. So go ahead and take a few minutes and again work through that formula and see if you can do that on your own. And then I'll show you, work through it with you in a few minutes. All right, so if you've had a chance to take a look at this question, again, we are using our formula, and let's do it in black here. So limit as x approaches a, f of x minus f of a over x minus a. Easy to remember, you have your x's first and your a second on both top and bottom, okay? So if you want to find f of a right away, you could, like f of 2, because a is 2. That's no problem. If you want to do it up here, that's fine, like I'm going to do here. So the limit as x approaches 2 now. F of x is x squared minus 6x plus 5. Okay, that's your f of x. subtract, and again, f of 2 is going to be, this is positive 2, got that right. 2 squared minus 6 times 2 plus 5. On the bottom, we have x minus 2, okay? So you simplify things here, and we'll leave the first part alone. And what do I have here? Well, can I just figure this out in my head or whatever? That's going to be 4 minus 12 is negative 8 plus 5 is negative 3. So I'm subtracting a negative 3 all over x minus 2. So this is x squared minus 6x. 5 plus 3 is plus 8. And over here on the bottom is x minus 2. So I've kind of completed the first stage there. Now I need to factor the top, this trinomial, to see if I can eliminate a factor from the top and the bottom. And yes, all of our examples have sort of been the same type so far, but as long as we can kind of get practiced on this overall structure, then you'll be fine. There'll be some more examples coming up of different types of functions too. We've just been focused on the quadratics, haven't we? So this is going to be x what? Minus 4 times x minus 2, right? All over x minus 2. Well, that's great. We have an x minus 2 on the top and an x minus 2 on the bottom. So we've got the limit as x approaches 2. This actually simplifies to x minus 4. So if I plug my 2 in for x now, I've got 2 minus 4, and it looks like this slope is negative 2 here. So the slope of the tangent line, because we've used the format of a slope of a secant line, and we've let x approach a using our limits here, this simplification with substitution at the end gives us our slope of our tangent line. And my OneNote just disappeared. All right. So any questions about this one right here? Okay. Okay, real good. There would be, let's see, what time is it? You know what? We're going to pause for a break here now. We haven't had an official break here yet. So let's go for a 5-minute break. I need to help a couple of the students, a couple of the things. And then we'll come back and we'll do this one question, and then I'll let you off on your first part of your assignment there. Okay, so here's a different type of question, a different type of equation. All right, this is a square root function. And so can we do the same thing for a square root function? Yeah, we totally can. So this graph is going to look something like this, right? So can we find the slope of the tangent line at the point 6, 2? So 6, 2 would look something around here. We're going to try and find the slope of the tangent line here. So yeah, we look at the limit as x approaches what? 6, right? This is always the x value. The x value here is 6. And f of x is root x minus 2. And f of a, right, is actually 2. So that's given to us already. So f of x minus f of a. F of x minus f of 6. And then over here is x minus a, which is 6. Okay? So that's your setup. And again, here's your, this was the formula that we're interested in. That's the one we're using. That's the one we're using. And here's it filled out now. So what I want to do here now, it's a little tough to liberate sort of this x minus 2 from underneath the radical sign. This is where we're going to want to rationalize our numerator. So we know how to rationalize. So let's rewrite this. And I'm going to multiply top and bottom by root x minus 2 plus 2. Okay. And this, so the top here becomes a difference of squares, right? So I could just square the first term and square the second term and write a minus in between. That's what that turns out to be, so it's awesome. So I have x minus 2, that's the square of this times this. And then I'm going to minus 2 times 2 is 4. That's a difference of squares, so that's what we end up with when we do the FOIL method there. Okay? Turns out to be a difference of squares. Now remember, I mentioned before that when you're rationalizing, maybe you don't have to expand if you're rationalizing the numerator, you don't have to expand the denominator all the time. You can save that because, again, what we're trying to do is we're trying to eliminate factors. So leave this in factored form. This is what I'm saying. So x minus 6 times, and let's just leave that as root x minus 2 plus 2 on the bottom. See that? Because if you notice, x minus 2 minus 4, that actually turns into, and I'll rewrite that because you're going to probably have to rewrite that. That actually turns into x minus 6. So we have an x minus 6 on top, and we have an x minus 6 on the bottom. Those factors are going to divide out. And we're going to have 1 over square root x minus 2 plus 2. So we've taken a rational function and we've put it into a different form. Now, is this going to be okay? Can we simply substitute to estimate the limit, to approximate the limit? Well, 6 minus 2 is going to be 4. Square root of 4 is 2 plus 2. That's not going to give us 0 anymore. So this is going to be 1 over square root of 6 minus 2 plus 2. That's going to be 1 over root 4 plus 2, or 1 over 2 plus 2, 1 over 4. Now I got my signs, should be okay here. And so, yeah, it looks like the slope of this tangent line is going to be positive 1/4, which makes sense if we take a look at this graph that we sketched out earlier. Okay? So there's another tool, another skill, a tool in your tool belt that you can use. Rationalizing will help us with some radical functions. Okay. We are going to be prepared for part 2 here shortly, but that's going to be the instructional video today for part 1. And again, this is our formula. Go back to the very beginning here. This is the formula here that we've studied today. This is formula 1, finding limit of a function using, finding slope of a tangent line using limits.